Hi, so this is my Doubly list CA, and I'm gonna run through the app first and then the code after showing how it runs. So I'm gonna just insert players into the list. So it's one, and the position. So no matter what number I enter here, it will just put it to the head node, to the first node in the list, the MH. So if I put 99, it will still be added as the head. The previous pointer is 0, next pointer is 0, and this is the current address. So I'm gonna add more, and I'm gonna just put in the duplicate first in case I forgot them. And put in some weird level and weird numbers that can remember it. I'll put it at the last node so that it would just iterate through the whole list. Okay, so it's added to the tail, and now I'm gonna add more. And this I would put it in between the first and the last node. So I would just put it in the position 2 in between them to show you that this is inserted, and the previous pointer is pointing to the first node, and the next pointer is pointing to the last node, which is the MTIL, and this is the current address here. And it takes 6 milliseconds. And I will continue to insert more now to show you the insert function with the positions. And so this I'm gonna put it in the end of the list. So everything which is larger than the list size should be just added, like append to the last node of the list. So you can see that the next pointer is 0 because it's the tail node. We'll just add 2 more in. And this I will just put it in the front to show you that it works, because you can see here that the previous pointer is 0 and the next pointer is pointing to the next node, which is the previous MH. And the last one I'm gonna insert. And this I will just insert at position 5, which is the one before the MTIL node. So this is pointing to the MTIL, and this is one before this node is inserted. So now I've insert 1, 2, 3, 4, 5. I've insert 6 nodes, and I will just run 3 to print all of them, 1 to 9 range. So we have here 6 nodes, 1, 2, 3, 4, 5, 6. Okay, and I'm gonna now try on the remove all duplicate. So if I run this, element deleted, and it took 1 millisecond to delete that element, but it takes 4 milliseconds to go through all the list and check if there is other duplicates. And now we can go back and check if it's deleted. So now there's only one Audrey in the list, the other one, which is a duplicate, is deleted. So we have now 5 items in the list. 1, 2, 3, 4, 5. Yeah. And it takes 7 milliseconds to find M from range 1 to 7. And since we're on the search, I will just go and show more on the search function. And here we have a couple of level 1, so I'm gonna just go for one. This is a single search, so and there's three players in level 1, or I can go and in the range maybe like 1 to and 2, that in between those who are in level 1 to 2. And to search the first name, we just return the details of the person that I entered. I'll just search another one. So here it is. And it's better now that I show you the average experience point. So I have 3 players in level 1, so it's better to use level 1 to get the average, and it's 133. It's 100 plus 250 plus 50 divide by 3, and there goes 133. And so now the last function is to delete a record from a particular position. And it's better if we print out all the players first. So okay, the first is Miley Cyrus, and I'm gonna just delete the first note. Element deleted. So let's go back and check it. 1, 2, 9. So Miley Cyrus is gone, and we have only 4 left. I will just do one more, like 1, 2, 3. Okay, we delete Katy Perry at position 3. Okay, and we can go and print out 1, 2, 9. So now Katy Perry is gone, and we have 3 left in the list. And that's basically what this app does. And I'm gonna show you my code. So this is my main app.cpp, and it's just basically a boolean, and it goes until boolean returns true. And this, I think I will go first to Doubly linked list because it's the main part of the whole CA. And so I have the list node class, which includes what is in the node, the m data, the pointer to the next node, and the next node address, and the pointer and previous to the previous node address. And the constructor is constructor, and I have all the getters and setters for the node, and I have this set start previous to null, which is easier if it's the header node. Then I can just set the m previous to a null pointer, and same goes to this and set n to null to set the last node's n next to null printed. And this print is just basically to check if my nodes are added at the right place, pointing to the right previous and the correct next address. And here I have my d-linked list class, which includes the pointer to the mh and mhead, and the pointer to the mtil. And there's the count here to count the nodes in the list, or you can call it the size of the list. and I have constructor, destructor, append, and the complexity of append when it's finding the node and its order n, and if it's inserting the node it's order c, because inserting a node doesn't need to move the other nodes forward, or it just does with the pointer. So inserting the node, it's order constant, and finding the node, because it needs to iterate through the whole list, so the order is order n. And append, it just basically goes and check if the mh is empty, and it inserts first element, which I have the function here, which it inserts the node, like set the data and then set the nodes previous n previous to now, and then set the new nodes n next to now too, because there's only one element in the list, and mh equals new node and m tilde equals new node. And else, if the list is not empty, then it just append at the back, set the new node, add the new node at the end of the list. So that's what basically it does. And it goes like new node and set the previous to the current mtil, and set the new node's next pointer to now, and then set the new node's data, and then set mtil as new node, set the new node as the mtil, and then now the new node is the mtil, and mtil get previous, which is the previous mtil set next to current mtil, and that's it. So I have a few functions here, which is convenient for me to use it later. And insert first element, which is to add the node at the head of the list, so it's a order constant order. And this prepend is to add a node in front of the list, so it's another order constant because it's just inserting the node. And this is function to insert the node in a particular position. So same as append, finding the node is order n, and inserting the node is order c. And insert function, it checks if mh is empty, and if it's empty means that the list is empty, so it just insert first element and count plus plus, and if the position entered is equals to 0 or 1, which is the first place, then it prepends the data. If the p position is larger than the n count, which is larger than the list size, then it would just append the data. Or if the position is equals to n count, which is like maybe there's only 2 things in the list and they want to put something in position 2, so it would just move the mtil forward and put the new node in between the 2 nodes, put it before the mtil. And else it would just iterate through and go to the position and just add the node in. And remove function, it's remove a node from particular position, and it's same, finding node it's order n, deleting node it's order c, as it needs to iterate through to find where to remove, and to remove the node is just moving the pointers. So it's other C. And it works the same as inserting a node, but the difference is you don't need to create a new node. You just delete it and then you just connect the pointers. So I have three functions here, which helps to makes it more convenient for me to code. And it's here empty list, remove head, and remove tail. Three of them are all others. And I have another function here which is remove iterator, which remove the node with the iterator. So it just basically does the same thing, but it's just working with the iterator, and it just goes and I need to go like iter.get node. And okay, and this is the preview functions. And I have my get iterator, which returns the pointer to the iterator starting from m height, and count return integer, which is the size of the list. And fill list is basically it's something that I didn't use inside, but I was using it while I was trying and fixing the stuff. And here is my dlist iterator. There is a pointer to the m list and pointer to the m node, the node which I'm currently in, the iterator is currently in, and all the getters and setters, and start, which is the start of the list m height, and fourth, which is moves to the next node valid until the node is not equals null pointer. The item, it returns the reference the reference of the item, and move to previous and move to next, which I created but I didn't use them, and next item too, I didn't really use them in the code, but yeah, I just used them there. And so next is the database.h. Is, I think it's the second important class in this CA, and it just contains functions for storing and managing all players. And I'll go through the functions here: the constructor and the constructor, and insert player. It just use the function that I created already in Doubly list to insert the player and the position. And remove iterator, which is also what I have already, the function that I have already created in Doubly list. So this is search single and return vector of players at particular level. Okay, so the user can enter this level that they want to find, like every player in this level, and it would I have a vector created here, and iterator to go through the whole list of players. So I go iterator start and for loop, and if the item dot get level equals p level, then it will push back to the vector. It would add append to the to same level vector. And yeah, so it just basically put all the same level into a vector, and that's it. I don't think I used this anywhere, if I'm not wrong. and its other end because it needs to go through the whole list to get every player at a particular level. So if there is more player, then it needs more time to iterate through. And search range, it's a search level function, because in this function, um, it takes a string and then it goes through the regex and to check if there's a hyphen or not. If there's a hyphen, then it's a range, and if there's no hyphen, then it's a single search. So it would just get this p string and p to search, and then it checks the regex, and it puts put there is three groups. Group 1, which is a digit, and group 2 is a hyphen, and group 3 is another digit. So I put the first group and the third group into first num and second num. And this is to change from string to integer, change the data type. And so it goes and check if group 2 is a hyphen, and if it's not a hyphen, that means that it's a single search. Okay, actually I did use the single search here. And so there is so it would just go in and check this one, which is um which is integer from the first group, which is a digit. So it would just go and check, and if the same level vector size is equal to 0, means there is no player found. And if it's not 0, then it would just go into a for loop and print everything in that vector. Else if there's a hyphen, then it will check if the second number is bigger than the first one. If it's smaller, then it would give the error message and return. Else it would just go and iterate through and get all the players which is in between this range. And if counter equals 0, then it means there is no player found. And yeah. So search first name, it just get the string and go in and iterate through, and if it finds the same name, it would put it in the vector, and if counter equals 0, that means that there is no player found, and then else, and it would just print out the vector, everything in the vector. Average XP, it's order n. I think I missed it. And search first name is also order n, as it needs to go through the whole iterator to find if there is any same first name. And if there is more item in the list, that means it will take more time to iterate through every node in the list. And average XP, it's also order n because it's the same, it uses iterator and it needs to iterate through all of them. And yeah, so average XP is just it just use the search single again, and it puts it in a vector, and it would add up the total of the XP in the vector, total it up and divide by counter, like how many item is there in the vector. I could have used same level dot size here, but it's okay. And remove duplicates. And remove duplicates is also other end because it needs to go through all the iterator again. And so this is my remove duplicates. This actually took me 4 days to figure out, and I still can't figure out. So I kind of like get help from Lucas. And so it just go through an iterator and go through the first one, and it puts the first items first name and last name here, and then it will go and check in this function, and it would go in the iterator and check the first name and last name. So when it goes the first time and it gets the same name, it would add put counter to 1. So if it comes again, the counter would be 1, and then it would just remove the second item which is in the list. And then change would be equals to true, and count would be set back to 0, and it needs to put ether back to start because I was trying to do ether.move to previous, but I don't know why it's not working. So start is the alternative choice, I think, to get this thing working. So I would just put it back to start and iterate through the list again to check if there's another duplicate. And if it's changed, then it would return change to true, and it comes back here. And then if change equals true, then the iterator needs to start all over again, because if there's a change in the list, then the iterator might not get the info, and it will just iterate through the old list not removed, which the node is not removed. So yeah, so that's just my remove duplicate, and it returns a boolean, and it checks the boolean here. And print all is just testing function. And here's my player class. It contains implementations of player details. So it's just the player detail, the getter, and the setter. And this is just basic player class. And I have my menu here, which is showing the main menu and parsing the user choice. And it's just I didn't do much with the menu because I think it would take me another day or two to get this done. So I prefer to stick back to what I'm still comfortable with, and yeah, it's just go through and search choice equals, and yeah, this is the menu, and this is add player, so it's easier and clearer to see it on other function and return the player. And this is to parse the user choice integer, like if the input is supposed to be integer, then it only takes integer, and it will show an error message when something which is not integer is entered. And string, you can just enter anything, so nothing much really in this function. And I think that's it for my code, and I hope you like it. And thank you for watching.